This video is just going to be more examples of finding the inverse. So I'm not going to do quite as much explaining about what I'm doing because I assume you've watched the previous two videos. And instead, I'm just going to go through the steps to do it. So if you're not sure what an inverse is or why I'd want to do those things, you might want to go check out those other two videos. We're going to try a different function for f of x this time. Let's look at f of x equals x squared plus 1. So that's a more complicated function. It's got a squared in it. So I want to find, I start by, well, y is equal to x squared plus 1. Then I need to invert, change my y's to x's, change my x's to y's. So now, well, that y becomes an x. That x becomes a y. That plus 1 just comes along. And I need to solve for y. And in this one, I'm going to run into a little problem. It's kind of a problem. We can think about what a big problem it is when we get there. Now, the first thing I need to do, get that 1 on the other side. That's not a problem. I can make a 0 pair. That is well within what I'm up to dealing with today. Well, great. X minus 1 is equal to y squared. Oh, I wanted to solve for y. I've solved for y squared. Well, I can square root it. But here's the thing. When I square root something, there are two different things that could be going on because squaring a number is lossy. Here's a quick example of what I mean. If I've got 2 and I square it, that's 4. If I've got -2 and I square it, well, a negative times a negative is a positive. That's also 4. So if all you know is I squared a number and I got 4, you don't know. Did I have 2 or did I have -2? It could be either. There's no way to know. And that's why this is plus or minus over here. We don't know. We don't know. It could be either. And because we don't know, and it could be either, that means that we need to keep both things it could be here. And this is the inverse of this, but it's going to give us 2 guesses, which means it's not a function. So we'd have to break it up into 2 separate functions. But it is, in fact, an inverse. It's just not a function. So that's weird. That's a thing that can happen. Now I'm going to give you one more example that's not quite as weird as that one, but you know, it has a fraction in it. So if that makes you happy, stick around. We're going to call this one g of x because I've already used f of x in this video. And I'm just going to show you one that doesn't come out as nicely as some of these, so you don't get it in your head, oh, these always come out nicely. There's nothing that ever comes out not nicely. Maybe I just made a mistake. So if I have something like, let's go with 2x plus 7 over 5 minus 2. That's got a lot more going on, but I can still get someplace with this. Let's see where I can get with this. Y equals 2x plus 7 over 5 minus 2. Then I need to invert. X is equal to 2y plus 7 over 5 minus 2. Once again, I just order of operations this, solve for y. Start by adding 2 to both sides, so I get x plus 2 is equal to 2y plus 7 over 5. Multiply both sides by 5 because that's what will get rid of that being on the bottom, because if I multiply this by 5 over 1, then I will get a big old 1 here. So I better multiply this by 5 as well. So this is just, you know, it's more complicated. I'm doing more algebra steps, but it's still the same fundamental process. Distribute that out, I get 5x plus 2 is equal to 2y plus 7. Make a zero pair with that. That'd be subtracting 7 from both sides. So then I'd have 5x minus 5 is equal to 2y. Put that over 2. Put that over 2. And I eventually conclude that this is my function. And this was messy, but this one is, in fact, still a function. So those are just a few more examples that might help make this a little clearer.